Well, I'd like to welcome everyone to our second symposium of a 4-symposia series on sustainable Benicia energy. My name is Constance Butel. I'm the chair of the Community Sustainability Commission, and it is our pleasure as a commission in partnership with Dominican University of California to welcome you this evening to the second symposium focusing on renewable energy. Part of the Commission's responsibility and opportunity is to do education and public outreach. And this series that we're doing is the third series that we've had since 2011. The first series was focused on stewards of our children's future. The second series with Dominican was on green business. And this series is on energy. Energy is our largest contributor to greenhouse gas emissions. It produces the most CO2 in our community, both as we consume it and as we produce it. As of 2005, Benicia produced 4.25 million metric tons of CO2 from energy production and consumption. Our goal is to reduce that by 20%, down to 3.6 million metric tons by 2020. We have an extraordinary panel here tonight. It is my great pleasure to welcome a personal friend and a California hero of utmost stature, Delane Easton. Delane served 4 times in the California Assembly. She was 2 times Superintendent of Public Instructions for the state of California. She has championed the issues of all of Californians, but particularly in her heart, I know, are California's children. Delane, thank you so much for making time to come. Delane will do an... Yeah. And we want to thank our other panelists. Delane will actually give an introduction to them, and their bios are on the back of the flyer that you have, and you'll learn more about them as we go forward. I want to quickly introduce some of our dignitaries in the audience today, our Mayor, Elizabeth Patterson, and our City Manager, Brad Gilger. And of course, all of you are critical to our important discussion about Benicia's future and sustainability for energy. We need a lot of intelligent thought, a lot of coming together to reason together about how we will sustain ourselves in the future. I would like to recognize our fellow commissioners, Raylan Fiscalini, who's in the back, Leanza Tupfer, our Benicia High School Commissioner, the Vice Chair of the Sustainability Commission, Kathy Carriage, and ex officio Commissioner Marilyn Bardet. So we're really pleased to have them here. And of course, all my dear friends sitting in the audience as well, thank you. We have a short film to introduce Benicia. To those of you who do not know and love Benicia, you will as soon as you see this film, and after sitting here and seeing what we're all about. And it runs for about 3 minutes, and then Delane, we turn it over to you in our forum. Thank you very much.
Welcome to the Sustainable Benicia Forum. My name is Delane Easton, and I believe that planning for a sustainable future is common sense. But as Mark Twain said, the problem with common sense is it's not very common. We are so pleased to have a stellar panel here tonight to discuss energy renewables in Benicia, wind, solar, tidal. Here we are in one of California's former state capitals, thinking about the future of a community within our state. Now, I admit we live in an interesting time when a commitment to learning about our history is ridiculed along with planning for our future. We are grateful, though, to Dominican University of California for sponsoring this event in partnership with the Benicia Community Sustainability Commission. In the best interest of this community and of neighboring communities, we have an opportunity to ponder where we are and where we are headed, even as we appreciate how we arrived here. I want to point out that sustainable thinking and planning is not some crazy new idea. I am struck that the very same people who criticize Sustainability Commission are now after the Historical Review Commission. Funny thing, previous generations thought about sustainable strategies all the time. If they did not, they were dead. I want to just give you a little quote from Elizabeth Janeway about life in the world in the 15th century. Elizabeth Janeway said, "Everyone got up at dawn, for daylight was precious, candles expensive. There was perhaps a great deal of work to do, for every house was in part a factory, producing not only farm crops, but beer and bread and cloth and cheese and often specialties for the market. And everyone had to be fed. On August the 1st, 1413, it is recorded that Dame Alice de Byron of Suffolk, England, entertained a friend, sat down to all meals with 8 of her household, and since it was harvest time, gave midday dinner to 17 more. All told, her pantry and kitchen supplied 60 loaves of bread, a quarter side of beef, another of bacon, a joint of mutton, 12 pigeons, and ale for all. We have to conclude on the evidence that over the centuries when this way of living persisted, Dame Alice and those like her were not simply housewives, but managers of farms and workshops. Their organization of food supplies had to be based on planning, which extended not from day to day or even week to week, but over the seasons and years," end quote. And in fact, my grandmother Easton used to sit down at the table with her husband and some of their 13, count them 13 children, and say, "I've raised everything at this table except the salt and the sody." The fact is that she spent the entire spring, summer, and into fall thinking about what they were going to eat that winter. That was just in the 1900s. The fact is, the concepts associated with sustainable living are not new, they are old. They are not frivolous whims, but conservative values that we must remain committed to. It should not come as a surprise that those who have criticized the Sustainability Commission have now taken aim at the Historical Review Commission. After all, the old adage, "He who knows no history is doomed to repeat its mistakes," is still relevant. The fact is that we have to think about planning for the future in this community, in this state, and in our nation. Do not think about the past. Do not think about the future. These used to be considered foolhardy notions, but now they're passing as some kind of new age thinking. The fact is that nothing could be further from the truth than to say that planning is bad. Indeed, most people in this room are aware that most corporations, and I worked for a large California corporation, most corporations have long-range plans of at least 10 to 20 years. Am I right? The fact is they wouldn't be in business if they didn't do strategic planning and they didn't have at least a 20-year window to look at in most companies like the ones represented here. And some of us are old enough to remember names like Sylvania and W.T. Grant, names like American Motors and Pan American Airlines. These companies failed because they failed to plan strategically for the future. Like corporations, governments must think about the future in a strategic fashion. If the state of Louisiana and the United States governments had observed the amazing work of the Netherlands in protecting its shores from cataclysmic storms, Hurricane Katrina would not have wreaked anywhere near the havoc that it did wreak when it hit the shores of Louisiana. We need to know our history, and we need to keep thinking about tomorrow. The state of California used to be peopled by pioneers, inventors, and long-range thinkers. We need to bring that thinking back again. The fact is, mind you, many of the big thinkers in our past were made fun of, but the truth is that Democrats, Republicans, and progressives who have led our state to greatness were always thinking about tomorrow, thinking about sustainability. Today we praise Hiram Johnson, Earl Warren, Goodwin Knight, and Pat Brown as governors who planned ahead. So it is appropriate that we gather today in our former state capital, and we do so remembering that we are standing on the shoulders of people who took amazing risks through a very tough time in our nation's history, through depressions and wars, in order that we could be here tonight. The fact is that now communities must take responsibility for planning ahead. Too often, I'm sorry to say, the government seems feckless in Sacramento. And it really is up to individual communities to band together and to think about what we can do to make this a more desirable place. So tonight, we are at the city's second symposium, and we are pleased to welcome 3 wonderful energy experts. John Bonds has joined us from the Ocean Renewable Power Company as an independent consultant to the largest privately held renewable energy developer in the U.S., as well as a U.S. tidal energy project and technology provider. John Bonds has been assessing North American and European tidal energy industries, markets, technology, and projects since 2005. Matthew Wilson is the CEO and founder of Foundation Wind Power, dedicated to establishing a systematic approach to bringing large-scale wind power solutions to rural industrial facilities in California and medium-sized utility-scale wind projects throughout California and the United States. David Hernandez is a project manager of Chevron Energy Solutions. Mr. Hernandez joined Chevron Energy Solutions with more than 20 years of experience in the design and construction industry, including program and project management on public and private sector projects in all phases, from entitlements and planning to design and construction. We are indeed fortunate to have these 3 distinguished experts with us. Gentlemen, thank you so much for joining us. I'm looking forward to this. Now, I'm going to just give you a little bit of the ground rules here. We're going to ask each of our panelists to present for up to 20 minutes. If they don't want to present that long, they don't have to. We won't beat them. And then we're going to ask each person, when they've completed, we're going to ask for questions from the audience. Those questions we ask that you write on 3x5 cards, and we have several people around. They'll wave their hands at you and tell you who can bring you a card if you need one. So we're going to have up to 20 minutes and then up to 10 minutes for questions for each person. And then at the end of that time, we're going to give our speakers a chance to question one another. And then we can come back, and if there are more questions from the audience, we can receive them at that time. So feel free to pass in your question cards throughout the symposium. We'll collect them and try to proceed.
I brought a presentation that has 34 slides, and I'm supposed to talk for 20 minutes. So I'm going to go really quickly. So I'm kind of a graphical guy. I think with pictures, and regular PowerPoints with a lot of words on them put me straight to sleep. So I'm going to try and not do that with you. I applaud Benicia for trying not to do any of those 3 things. If you can't see it, it says California is Greece, and California is Egypt, and California is Never Neverland. But I think it's great you guys are looking forward to doing things a little differently than the rest of the world. Next slide, please. What is tidal energy? Tidal energy is capturing a piece of the energy that is in moving water. Not all of it, and this is the water that moves horizontally, not vertically. Wave energy captures the energy of waves generated by wind on the surface. Tidal energy is from the amount of water going in and out. Some people like to think of underwater wind farms. Next slide, please. Tidal is not yet commercial. You don't see huge tidal farms anywhere in the world. They are starting, but you won't drive through Altamont Pass or anywhere else like that and see a bunch of, like you see a bunch of wind farms. Those are not yet existent. The reason is it's very hard to do things offshore, and most of the efforts are being done a long way offshore, and deployment and operations and maintenance are very expensive. And the other part is that everyone owns the ocean. When a wind developer wants to go to Farmer Jones and says, "Do you want to put a cell phone tower up, and I'll give you some money?" Farmer Jones usually says yes. And similarly, it's not as difficult with wind. To put any device in the ocean, approximately 26 overlapping federal and state jurisdictions, agencies must all be consulted, and because it hasn't been done before, it's a very exhaustive process with a lot of education going on. On the slide are a lot of funding that is going on for tidal energy, and there are numerous commercial projects going on worldwide, mostly focused in northern latitudes, Scotland, Ireland, UK, Alaska, and Maine, because the tides are bigger there because of the way geography and the lunar cycles work together. Next slide, please. That is marine current turbines. They are in Strangford Lough in Scotland. If you can look closely, there are two propellers on that cross arm, and in the top right corner you can see there's quite a bit of moving water there. That's 6 knots, also known as, no, that's about 8 knots. It's about 16 meters a second. And those opportunities don't occur many places. That's been operating for quite a while, and Siemens just bought 52% of that company. Next slide, please. That's what they envision looking like with the whole deployment of those pylons. Next, please. Next company is Open Hydro. They're an Irish company. That is a disc that is 10 meters across. The top left slide shows that it's on a triangular base. The base is suspended beneath the water in the bottom slide, and you can see how big that machine is on the top right. Their next one is going to be even bigger. That was deployed in the top of the Bay of Fundy off of Nova Scotia 2 years ago. Next, please. That's what they look like on the bottom. Each of those is expected to generate 1 megawatt. That's enough for 1,000 small homes. Next. This is Verdant Power. Verdant Power is deployed in the East River in New York. It's a U.S. company. That is a downstream facing blade. The upstream is to the right in that picture, and it pivots with the tide. Next slide. The blue arrow on the top is where they are deployed. The yellow arrow on the bottom is the United Nations building. That's the East River. Roosevelt Island is in the middle. They have just received their FERC license from the Federal Energy Regulatory Commission to deploy 15 megawatts right there in front of the United Nations. Next, please. This is Verdant on the top two. The bottom is Hammerfest Strom, a British company, and on the bottom right, I believe, is Hitachi. Next, please. This is Free Flow Power. They are in Massachusetts. They intend to put these devices all the way down the Mississippi River. They have filed about 100 different permits. Their device is pictured on the bottom right. You can get a sense of scale by the dude there. They envision putting these on pylons and on existing bridge abutments crossing the Mississippi and in downstream of some locks in other places. The U.S. Army Corps of Engineers is very excited about these guys for a lot of different reasons. It helps them do things they want to do. Along those lines, I didn't reiterate a point that I did write down on my previous slide, which was that this generates hydroelectric energy without dams and without fish impoundment. Next, please. This is Ocean Renewable Power Company. They are in Maine. They have projects going on the Maine side of the Bay of Fundy. So if you imagine a map of the Atlantic Ocean and Maine coast, they are right there at the tip of Maine. While you're looking at that turbine, you're on Canadian cell phone towers, and it's a very expensive place to be if you answer your phone. The unit in the top background is their beta unit that they were testing. The bottom picture is what they are about to deploy later this month. They just got their FERC permit 2 days ago to deploy this device and another. It will be a 5 megawatt installation. That device on the bottom is 100 feet on each side. Next slide. This is a different idea. This is biopower systems, and that thing pivots left to right. The current is moving in that picture from right to left, and this moves like the tail of a fish. The term is biomimicry, where we try to imitate what nature does well, and there's a power takeoff device in there. Next slide, please. This is New Energy Corporation. They are in Canada, and this is a little different look. It has vertical blades, and the idea here is it's for smaller scale stuff. As I've moved down these slides from beginning to end, these are smaller and smaller scale devices, going from huge industrial, commercial size to smaller community-based. The idea here is that the electronics in the generator are above water and don't have to be encapsulated anywhere. It's easier to deploy, and these are being sold to communities that are in Alaska and Canada that are now running on expensive diesel power. Next, please. This is an idea by Blue Water Company. The Blue Water Corporation builds those huge buoys that ultra-large crude carriers come up to instead of going into port and offload. So these ginormous buoys. They build big metal things. They want to build more big metal things, and that yellow thing is a big metal thing with hydrokinetic devices attached to it. It's a concept. Next, please. This is one of my favorite pictures. This is an overlay of bathymetric data on top of geodetic data. The Golden Gate Bridge is the red thing going across. San Francisco is on the right. The Marin Headlands are on the left. The big blue bit is the very deep bowl that is underneath the Golden Gate Bridge. We look out there and don't realize what's going on under the water. It's pretty complicated. Alcatraz is the island on the middle upper right. Angel Island is the island on the middle upper left. And you all are where we're sitting right now is up there way past the top left corner. But I put this in to indicate that what you see under the water is a lot different than really what you normally imagine. Next slide, please. This is another example of bathymetric detail. And in order to capture tides in any one place, you can't just go put a turbine down there and expect it to work out well. You really need to know what's going on. Extensive studies are necessitated for a bottom like this. This is obviously a very complicated place, and out here in the river isn't as bad. But that's a pretty picture that I thought you all might enjoy. Next, please. This is another bit of bathymetric data. It's a river. I believe this one is in Alaska, and it shows silting on the sides and scour where the deep blue is. That's one narrow river with a lot of different variances in depth. Next, please. This is a detailed assessment of the bottom that someone did up in Maine, so they could figure out where to put turbines and how they would go on the bottom and whether they would stay put, whether they would sink, what kind of attachments would be necessary. What I'm trying to walk you through here is a bunch of pretty pictures showing how much work is necessitated before you can put anything in the water. And these are all actual studies done in different places. Next slide. This is us. All the little figures up in the middle are tidal stations that the government has been maintaining and measuring data. I found a tidal current book, and for those of you that spend any time on the bay, you can get them at bait shops and other kinds of places. But they're all based upon studies done in 1923 where crews went out on boats and measured for a week at a time. And this is the historic data that we still use 90 years later. All of those sites are on there. And so Golden Gate is on the lower left, and we are in the middle. And if you go to the next slide, it'll zoom in a little. That's where we are. This is a navigational chart for where we are. And it shows that all the little numbers in the white show our depths, and they show that it's pretty flat. It's a standard river bottom. It's deeper on the outside like most rivers, and it's shallow right offshore where we are. We are sitting in the yellow bit in the middle top. So south is to the bottom and north is to the top. Next slide. This is a zoomed-in picture that shows a little more data, and the railroad bridge is over to the right. The shipping channel is on the bottom, and that's where most of the current flow occurs here. There's less flow that occurs in the flats up on the top. For those of you that spend time on the water, you probably are aware that the flooding current from the ocean water comes in on the deep stuff, and while some of the less saline water from river flows continues in the flats a lot of the time. It's an interesting place. Next slide. There's a Google Earth picture, and that shows the tidal stations where measurements have been made historically around here. And the figures in red are how big the currents are. If you can't read them, the maximum currents we get here are about 2 knots. That's not a whole lot compared to the places where they're putting the big devices right now. Next slide. This is the Amorco Pier across the river in Martinez. And this shows, I've superimposed 2 bits of data from yesterday. And blue is predicted and red is actual observed. And I believe they peak out right just below 2 knots. Full moon time, we get about 2.1 knots there. And that's maximum. That's not all the time. And devices don't go around in water that isn't moving. Next slide. The big question is, can tidal energy be done here? What that is a number of days worth of data. The peak flow is in the peaks on the top, and the big areas in white show that there isn't a lot of flow. The flow does reverse, and while it's shifting, it goes pretty slack. Next, please. The way you find out more about your data, more about your current, is you put one of these devices down. That's an acoustic data current profiler. It's in a little housing, and basically it gives you, like color weather radar, Doppler, of what moving water looks like. Next, please. You throw it down on the bottom, you get 30 days of readings, and you can see how fast the water is moving over time. And if it's a side scan, you can see what it's looking like in different places in the channel. Next, please. This is the California current offshore, and it's too small for you to see, but there's arrows pointing in all kinds of different directions. The San Francisco Bay is the little hole in the host up on the right. Every one of these graphs that I've ever seen where people have taken data from sophisticated devices and graphed it has shown them things they didn't expect. Every single one of them. Next one, please. This is looking across a riverbank from one side to the other, and it shows intensity of flow in different areas. The green is, I think this one is one direction and then the other, in a tidal estuary. The green flow is more strong current than the other. Next, please. This shows that the current is not distributed in different places. The black bit on the top is because the water went down. It does show that you get different speeds in different places in the water column. It's not uniform or linear. Next, please. This was a study done when Mayor Newsom was looking hard at tidal currents underneath the Golden Gate Bridge, and this is done at different parts of the tidal cycle, and it shows different intensities, vastly different intensities. Next, please. This is a surface map of what the tides look like at different points in the tide with arrows. We are off the scale of those up in the top right of each picture, but it shows the distribution is all over the place, and the intensities are shown by the data getting graphed in this way. Next, please. This is a summary of both of those, showing the geographic areas where you get the most pressure on a device or on a measuring thing. So when you combine all the data together, these are the most opportune spots in the bay, in the lower bay. Next, please. One of the questions that was posed to us is, what are the environmental effects? This is some researchers who work at a government laboratory and want more work. Their idea of all the things that might be studied. I have a personal problem with entrepreneurs and government employees making long laundry lists of all the potential negative environmental effects they can think of that they want money to study for a couple of years before any testing can be done. That's just an interesting matrix, but it's everything under the sun. And if you have any more ideas, they'd love to hear about them. Next, please. This is what Benicia might want to think about. Do you wish to consider tidal energy? And if so, why? I've read through the sustainability plan, and there are a couple of different metrics in there. It describes that you want to mitigate carbon production. So any sort of renewable production would offset a little bit of conventional energy generation. Are we looking to do this to save energy? These guys may be able to save you some energy. Tidal energy, it'll save you some energy, save you some money. These guys are going to probably save you some money. This won't. It's expensive. It's not there yet, but it's coming. It's probably worth studying, and the devices are getting better all the time. But right now, they're very expensive for the reasons I delineated earlier. I can't read my slide from here. Maybe you can, maybe you can't. I pretty much said, I think, most of everything that's on there. Next slide. If you do want to consider tidal, then we need better data for what's nearby and what you all think you could do politically. Everyone is going to say they own all the water out there. But I think a study would be well received, and it would be interesting to see what's going on. And I think a lot of the device developers, if there was a little more data, could be made a little more interested. If the data analysis shows that there's not enough current out there, you looked, and you'll know. Next slide, please. So, like I just said, are the currents adequate for today's devices or tomorrow's devices? We really don't know. The data that we have is very small points that were measured not with sophisticated devices, but by men in boats. And next slide. That's me. That's it. How'd I do on time?
Great. Well, here's a rather technical one. Once the peak flow part of a river or strait is determined, does it ever change location, or does it stay the same?
It doesn't just change every day. It changes at different tidal cycles, especially here when you get a lot of runoff from melting snow in the spring. That will change the composition of what's in the river and where. So the answer is there is a best spot, and you can look at it, but you really need to look at the current for a long time to figure out where it averages out with the best pressure.
Cool. All right. So here's a question. How do the underwater turbines affect fish and other wildlife?
If you're really interested in this, you can look at the Department of Energy's website. There's a division called the EERE, which is, guys?
I don't know. Something with me?
It's where the renewable energy stuff is on the Department of Energy's website, and all of the all of the evaluations regarding environmental effects are on there. There is one study that is particularly well done by the University of Washington State, and it's over 100 pages long with a lot of pictures and a lot of links to other things, and it's only about a year old. There are numerous studies that have been done. The initial answer is that we don't see dead fish behind bridge abutments. They tend to not run into things. Most of these devices do not move around very fast. Most of them move at the speed of the current rather than as a multiple of that. And they're fairly large. And the gaps between them are fairly large. And the studies we've done show that smaller fish don't like fast-moving current. They stay towards the edges of the stream. They don't like getting swept away. Medium-sized fish may come by, but not very close, and bigger fish just swim right by the thing. There's lots of data with underwater cameras and underwater sonar and other means of detecting what exactly marine life are doing. More than fish, people are more concerned about marine mammals, and extensive studies are going on with that. As of today, there is no documented evidence of ill effect on marine mammals or fish by any of these devices anywhere worldwide. But there are lots of people looking for it. Hundreds. Hasn't happened yet, but there's a lot of data out there.
Okay, I'm going to group a couple together here. What is your view about whether tidal may or may not happen in Benicia realistically? What kind of data do you need for tidal energy to become a more reliable source? And I'll come back to that other one. Let's try that.
Well, whether it will happen or not is a factor of two things. One is the technology ready, and two is the political climate ready. Everyone here is familiar with the term NIMBY. That means not in my backyard. Banana means build absolutely nothing anywhere near anyone. One of the rules of wind site development has been don't even think about putting up a turbine within 45 minutes driving distance of a Starbucks, because everyone will show up and protest. There are several others of those. NIMO means not in my ocean. NIME means not in my election year. So the answer to your question is twofold. The technology is getting there. Whether or not there's adequate current for today's devices here, we don't know. It's pretty easy to do a little more detailed study on places that we think might be politically amenable to putting a device in the water for studying. So it's more complicated than a yes or no answer, but that's the best answer I can give you.
Okay. I wish I could write faster. I missed some of those acronyms. How much does a tidal assessment cost? How does tidal power compare to wave power? And could tidal deliveries be used effectively on existing offshore oil platforms?
I'll start with the last one, and we're looking at that really hard. We've looked at it in the Gulf of Alaska, and it's being looked at for wave more than tidal in Southern California. And the oil companies are interested in it because they have to burn their own product in order to help those. They have to cannibalize some of the product they're making in order to make production there. That was the last one. Could you tell me what the other one was?
Sorry, the other one was, get organized here. I'm sorry, I've been.
Oh, how much for an assessment?
How much for an assessment?
$1 would be a good start, and $1 million would give you a lot of answers. And there's everything in the middle. Right now, there's very little in terms of detail about this part of the river that I'm aware of. I wasn't able to find any ADCP data at all. The way to do that would be to get university help with that, and they can tend to get monies for studying stuff. And community projects where communities rather than developers are looking at sites tend to be funded a whole lot more easily than the commercial ones.
Okay, here's some that are on same kind of wavelength. Are there any thoughts to mitigate the problem of the slack tide? Has anybody studied the energy producing potential of ships docked rising with the tide, lifting capacity, and how can tidal energy contribute to other communities attempting to reach energy conservation goals? What's the potential for tidal power in terms of the percentage of future use that it might generate?
Those are good questions and a lot of wide, varied ones. Ships moving up and down has been looked at quite a bit. That's a pretty expensive way to capture energy, since ships are steel and steel is money, and also real estate. That's a much more expensive way than turbines and not real efficient. And I know that there's a whole fleet of gray ships right up the river that people want gone anyway, so that's usually not real politically attractive. Things hidden underneath the surface are usually a little easier there. That was one. Can I see those again? Sorry. Mitigate the problem of slack tide. There's a number of different energy storage technologies being looked at for both wind and solar and tidal. They're expensive. They're a bolt-on, just like a hybrid car is more expensive than a standard electric or a standard gasoline car. Bolting more technology onto any project makes it more expensive. Yes, there are ways to do that. At this point, nobody's done it yet because it's just too hard. It'll probably happen in the next 5 years. It's a good question. Batteries or compression of air to be discharged later are all good options. And especially in this market where energy is very expensive at peak times during peak air conditioning loads and really cheap at other times, it would be nice to be able to discharge your power when you can get paid the most for it. How can tidal energy contribute to other communities attempting to reach energy conservation goals? I don't really know how to answer that question, but one of the things that's interesting about tidal is that it can be done in places that are completely off the grid, and we are looking at some places in Alaska where they actually have to fly diesel fuel in to keep generators working in the wintertime. That's a really expensive electricity, and it's not hard to compete with that.
I confess I'm still reeling from the idea that we're using these flow charts from 1927, did you say? Since 40% of San Francisco Bay has been filled in since then, so the flows have got to have changed dramatically.
They've changed quite a bit, and they've actually changed dramatically out here due to ending of gold mining sediment in San Pablo Bay. It's emptying.
Oh, wow. Interesting. Well, one of the questions was how much money was spent to analyze the Golden Gate flows?
I don't know, but I'm sure it was more than I could
$1.
check for.
Yeah. And land underlying navigable waterways and our sovereign public trust land, with the title held by adjacent cities to the center. Have you examined public trust consistency?
That's a good question, and it's the consistency is a word I would probably say is more inconsistent as we look more and more in different places. It's very difficult. On one of my slides, I put in who's helping, and the Crown Estate is helping. The Crown Estate is the people that have the crowns in the castle over in England, and they own the land under the water, and when they decide that something's going to happen with it, that's where it's going to happen. Here is a whole lot different, and it's an arduous process. The developers that have managed to do these first couple of projects have worked long and hard to gain public acceptance of the idea that these are good things to look at. This is one reason I said that a community-based effort for investigating tidal will be met a whole lot more readily than a big, bad, ugly, profit-minded, capitalist pig developer.
Thank you so very much. That was excellent. I really enjoyed that presentation. Let's thank John. Our next batter is Matthew Wilson, the CEO and founder of Foundation Wind Power.
Thank you very much. Thank you, Benicia, for having Foundation Wind Power here to present. Our company builds, owns, operates wind turbine on typically rural industrial facilities inside California that have large on-site loads. So you might have seen a wind turbine at Anheuser-Busch in Fairfield. That is currently owned by a developer, Foundation Wind Power, and our financial partner, U.S. Bank Corp. And we deliver 100% of that electricity to Anheuser-Busch. We also focus on mining locations, cold storage locations, and in the municipal space, places that move a lot of water and treat a lot of water because there's a lot of on-site energy load there. You can go ahead and go to the next video. So we were founded in 2002 or 2008 to specifically go after this market. It's a power purchase agreement market where we own the facility. There is absolutely no capital outlay by the end user customer. They enter into 20-year power purchase agreements with Foundation Wind Power, and we own and operate the wind turbine and deliver kilowatt hours to the factory or the plant. Go ahead. Next, and you know, it's kind of interesting the way we. If you want to go back just a second, go back. It's, you know, we've had a lot of success with a lot of private companies. We have done a turbine with the Inland Empire Utility Agency, which is a water agency in Southern California. But a lot of these private companies are moving quickly, not only because we save them money delivering green power to their plant operations, but they're increasingly being regulated by you know, the state of California, CARB, to reduce their carbon emissions. So they're actually moving forward and doing these projects not only to save money, but also to meet requirements around AB 32 for the case of the cement industry, and just good stewards of the environment. So go ahead. So you know, I came from Siemens. I came from Siemens. You know, we don't take technology risk. We put up really big wind turbines. Our smallest wind turbine can power 1,000 small homes. It's a 1 megawatt machine or 1,000 kW machine. These machines are made by Mitsubishi, Siemens, GE. We have great financial partners, and the list of our customers are down below: Safeway, Teichert, Budweiser, Inland Empire, Nestle Waters, who makes Arrowhead, Cemex, Robertson's, and a lot of the Walmart. A lot of these customers have sustainability goals like Benicia has. Walmart has one of the most comprehensive sustainability goals out there. They're the largest consumer of electricity outside of the United States federal government and the DoD. So these people are real about sustainability, but really large energy consumers. Go ahead. So this is typically what we do. We put up a wind turbine. When the wind's not blowing, you get electricity from your brown, dirty power from PG&E. And when the wind is blowing, you get clean, carbon-free power from a wind turbine. At Safeway, we put 2 1 megawatt wind turbines up there. Their load is about 3 megawatts. So when we're running, we're producing about 2/3 of a million square feet refrigerated distribution center. Go ahead. And just to go back, so all of these customers have signed, so long-term thinking around their carbon footprint. Every single one of these customers has signed a 20-year commitment. So they said, we're going to be here for 20 years, we're going to be operating in this location for 20 years, and we need to make a commitment for 20 years to become sustainable. As opposed to some of these other technologies, wind has is pretty well developed. It continues to become more efficient, larger swept diameters. But we can actually deliver electricity, and we have delivered electricity at or below PG&E rates and SCE rates to the largest energy consumers in California, so they pay the least amount. You probably pay about 2.5, 3 times as much as a large energy consumer in California. Go ahead. So this is what we look at. 1,500 kW can, or 1,500 or 1.5 million kilowatt hours is the equivalent of reducing 250 homes. A typical large-scale wind turbine will produce about 2 to 3 times that in a good wind location. So we always talk about not only saving money, but what it is actually doing and how much carbon it's reducing. So it's 2 points. I think it's 2 points. I can't read it. Sorry. Well, you guys can read it. It's a lot of carbon coming out of the air. That's for darn sure. And a lot of NOx, a lot of particulate matter, a lot of those things that we don't necessarily talk about. We always talk about carbon, but what effects do NOx and SOx have on your daily air that you're breathing, and asthma rates and all of those other things that are coming out of gas-fired power plants, coal-fired power plants, and so forth. Go ahead. PV versus solar. A lot of our locations, if you're at a mine site, you have a lot of space, but it's pretty dusty, as you could imagine, in a mine site. So you typically don't want to put solar there, and sometimes you're land constrained. At wastewater treatment plants, you have a lot of clarifiers going, and you don't have a lot of land. We actually lease a 50-foot circle and our footprint is actually 16 feet in diameter. It goes up a long way, but if you're looking at land use, if you don't have much space, if you're land constrained, it's a very good way to produce a tremendous amount of power from using very little land. So this is what it looks like. A lot of when Budweiser's so they were, just so how much excitement there was around the Budweiser, they put it up on their intranet. And when we were putting it up, they were filming it and streaming it on their intranet. And on their intranet, they got over 100,000 hits on their intranet, on their Anheuser-Busch intranet. So it's very exciting. It's very exciting for the community. These companies are very excited about it. And when you have a value proposition that not only says it's a great visible statement of my environmental stewardship, but I can save 10 to 20% on my energy bill, it's a pretty great thing to do. They are big. Go ahead. So typically it's about 80 meters tall, about 55 meters to hub height to 80 meters at hub height, and the rotor diameters are anywhere from 70 meters to about 100 meters in diameter. Go ahead. People talk about noise issues. They're actually very quiet. The new technology is very quiet. They're bigger, typically about 65, 55, 65 at dB. So as you move away from them, they're really inaudible. And when it's really windy, typically you hear the noise of the wind from buildings and other things. So typically we don't have too many issues around noise. Avian impact, I think the wind industry has gotten a bad name around avian impact, but if you look at how many birds buildings kill, automobiles kill, and I hate to say this, house cats kill. It's very minimal what we do. And upstream, coal mining, all of those things have such a dramatic impact, not only on climate change, but on the environment and how it affects mammals and avian creatures. I like cats, so. Yeah, I think there's a window of opportunity here. Unfortunately, our Congress is basically in deadlock, and they can't agree on anything right now, including renewable policy that goes out beyond a year. So right now is the time to move on wind until I think until probably after the election cycle, and we can agree that renewables makes a lot of sense. But we do have tax credits that are important for this developer. I don't know. I don't feel that I'm that greedy, but we are profit. We are motivated partially by profit, and our bank is motivated by tax credits and tax incentives. But we're hopeful that we get a extension to 2016, like solar has, so that we can continue to do these projects. Our 1 megawatt turbine will produce probably about 3.2 million kilowatt hours. Typically, a similar solar array, although peaking, probably does about 1.7 million kilowatt hours. So you get greater efficiency than some other technologies. I know tidal has some great efficiencies. Can have some great efficiency. So this is typically what we look for. We look for high energy consumption on site. That's probably changing with some laws around net energy metering and virtually net energy metering, so you could actually deliver the electricity and use it all over the city. So putting it in a location, delivering it to the grid, and then using it to offset the police station, the city hall. I don't know where that legislation is. I haven't been following it in the last couple of years, but I think it's coming back. At least that's what I've heard. Wind resource. You guys have an excellent wind resource here. We've actually studied it fairly extensively. We wanted to, we've looked at a project off of we looked at the wind resource off of Lake Herman Road, which is a treatment plant over there. So you have the wind resource. We use triangulation data, and that triangulates CMIS data, which is California Irrigation Management System data. So we know that your wind resource is good, and it's not hugely different from Anheuser-Busch facility, which is about 6.5 meters a second. Go ahead. So here are the maps. The great areas for wind in Northern California are really Altamont Pass, and coming through the Delta. It's really it's a pretty easy phenomenon to think about. We have this cold Pacific Ocean, and you have this hot valley, and the hot valley heats up, and warm air rises, and cold air rushes in, and that's what happens. So this right here is the power alley of wind resource in Northern California. So it's a great wind resource. Solano County is, Solano County is a very good county to permit in. They have a lot of, I know this is you would permit here, but typically we permitted in counties. Solano has, 200 or 300 megawatts in the Shiloh Hills and Montezuma Hills. Permitting issues, typically we have either gotten a negative declaration, a CEQA negative declaration, or a mitigated negative declaration, depending on what we propose. And the difference between what we're doing, we're putting it on site. We're not putting it in pasture land. Where we're putting it is not great raptor areas, so there's not as much. When you're put in an industrial area, it's just not a great foraging habitat for avian species. So this is a 390 90-foot wind turbine at the Teichert Materials facility. It's a great Sacramento-based company. It's been around for 1850. They were our first wind turbine commissioned about 17 months ago. Typically, it takes, we'd be on site for about 2 or 3 months building a foundation, and the erection takes, we're done in 2 days. They bring in about a 450-ton crane and lift this thing in 2 days, depending on if we're winded out or not. So we can't build when there's 25-mile-an-hour winds. This is Safeway, same thing, just right up the road at Tracy on the backside of the Altamont Pass. This is 1 million square feet of refrigerated distribution. This is their Northern California distribution center. So this is, I think, this distribution center caters to about 37% of their stores nationwide. Our friends up at Budweiser commissioned just about 4 weeks ago. This turbine creates 20,000 cases of beer a day. So that's Kevin Fink. So that's exactly what they did. They did the calculation. I think it's about 100,000 cases of beer coming out of Budweiser, mostly Bud Light. So we're doing 20,000 cases of beer a day, and they gave us 10 cases when we left. So thank you. This is Inland Empire. This would be very similar to what we're contemplating with City of Benicia. This is a water agency. They do both freshwater, drinking water, and reclamation. So this is at the reclamation plant 4 in Rancho Cucamonga. It's right next to clarifiers and right in the middle of Rancho Cucamonga, and 5 miles away from the Ontario airport. So if you fly into the Ontario airport, look down to the right, and there's a wind turbine right there. Again, these are our customer base. These are our customers. This is how much electricity they're producing. We've just closed our 5th fund, which is a $35 million fund with U.S. Bank. We're closing one more fund, which will be about a $50 million fund with U.S. Bank and Seminole Financial to build out the rest of our pipeline. We hope to continue with that, we're really excited to work with some more public sector clients. We just kind of a longer sales cycle typically than a private company. But we have as of Tuesday, the city of Vacaville just okayed that they will be negotiating a power purchase agreement with Foundation Wind Power. That's for a facility at a wastewater treatment plant. Yeah, I think we need to talk to the mayor and the city manager if this is something you want to explore. You have the wind resource here. I think you have the electricity load. It's really a decision. If you're serious about climate change and reducing your carbon footprint, this is a technology that will produce an incredible amount of electricity. It's proven. There's no doubt it works. There's no doubt it works on site in California, where we have some of the highest utility rates. These are just sample questions, but I think we'll get questions.
I'm sure your work for Anheuser-Busch has been appreciated by a lot of people. It was Ben Franklin, I think, who said, beer is proof that God loves us and wants us to be happy. So I'm going to put 3 sort of together. I think one you kind of addressed, but someone asked how feasible is wind in Benicia. Another one is, are 6-foot diameter wind turbines okay in Benicia? And do turbines have a bad effect on bats?
Yeah, I think it's definitely feasible in Benicia. It's you definitely have the wind resource. What the California Public Utility Commission rules on virtual net metering will tell a lot around that. You typically want to put wind turbines. You'd probably want to put wind turbines on the Lake Herman Road area and then virtually net meter back into the city. Typically, try to keep them away from densely populated areas, but definitely viable. I think you said 6-foot diameter wind turbines. I don't know. It's just not what I do. It's not commercially viable for our company. We put up large wind turbines that have proven track record. Both our company's investors and our tax equity investor, U.S. Bank, are some of the least risk-adverse investors out there. So we put up GE turbines, and that's what we do over and over again. Some issues with bats, but again, coal mining has much more issues with bat populations than wind turbines. So.
Okay, I'm going to put a couple together. How long does the permit process require in Solano County, and what are the maintenance costs and concerns?
Well, we just got our permit in Solano County for unincorporated Dixon at Superior Farms. It took about 6 months to get the permit. But in San Joaquin County, we're getting permits in 65 days. Tama County, we're getting permits in 65 days at Walmart. So it's a really a question to the lead agency, and City of Benicia is the lead agency if they control how long it takes to get permits. Yep.
There's one here that is the problem of bearing wear and maintenance well resolved for wind turbines? And then a second question, what happened at the Altamont Pass regarding wind turbines? Why aren't more working? Was the problem of so few working due to the end of tax credits?
I'll take the operations and maintenance question. The O&M for these large turbines is fairly well known. You typically have an operations and maintenance contract that's about 7 or 8% of gross revenue, and then you have a sinking fund for major maintenance, somewhere around the same for major maintenance. The Altamont Pass was mainly built in the older turbines were built in the 80s when they had a kind of different tax credit scenario where it didn't matter if the wind turbine produced, and so there's too many investors that put up wind turbines that didn't really need to produce to have the economic outcome that they needed to. That has changed. They're going to be repowering the Altamont Pass with larger wind turbines that have a bigger rotor diameter that are going to be both much more friendly to the raptor population out there, but also removing about 8 of those smaller wind turbines for one larger wind turbine and producing about 2.5 times more energy in that 8-for-1 takeout.
Okay, we got one that says, could you develop enough wind power here to power both residential and commercial users? And what is the cost to erect a wind turbine? In other words, that would supply power to 250 homes, let's say.
I mean, there's no doubt that wind turbines could provide power to 27,000 home or 27,000 people in Benicia. There's no doubt about that. I don't know. The real question is what your industrial users use. These big oil refineries, I'm sure, use a tremendous amount of power. But I don't think there's any doubt that 100% of your electricity delivered to your residents could come from, I don't know, somewhere around, maybe 30 large-scale wind turbines, I would think. And the cost of a wind turbine, again, if in our model there is no cost to the city of Benicia, we don't build, own, and transfer wind turbines. We actually own wind turbines for 20 years and sell power at a discount to PG&E to our end user customers. Every single one of our customers has not even asked about it. They focus on, they focus on the operations of their facilities and delivering groceries and making beer. So that's what they do, and that's what they focus on.
Okay, we have, what is the state of development in industrial battery storage for wind power, and what would be the prospects for a wind farm at Benicia Industrial Park?
I don't know. I really haven't looked at, we looked at the ridge top above the refinery just off of 680, and delivering power to that Valero station is kind of one of our thoughts around there. We haven't talked to Valero, but the wind resources there to deliver power there. So there's great potential for wind resource in delivering to the grid, potentially delivering directly to the grid, but also potentially using batteries. We are looking at battery technology currently, mostly to load shift. To John's point, if you can deliver electricity back to either the customer or the grid from 12 to 6 June through September, you're getting about 2.5 times the price of electricity. So we're looking at battery technology to basically load shift our clients so we can deliver peak energy to them, deliver off-peak energy to them at peak when it's most.
That's exciting because it relates to this question. Some have argued that wind and solar power don't really cut GHG emissions because you still need the backup power. How true is that?
Oh, it's completely false. It means that a peaker plant does not have to run. Yes, you do need backup power. However, the power stations aren't running, and when they're not running, they're not emitting greenhouse gas. So, I was out today at Shiloh, and everything was rated. That meant that there was a power station not online, and that means that greens are not exhausted into the air and polluting our environment. And I think, I think battery technology is going to increase that, especially end of line. Battery technology strengthening the grid and making sure that spinning capacity like wind and solar come online effectively and don't have a negative effect to end of the line grid.
Let me address that.
The battery question is a good one, and currently under the way that grants and from DOE and other tax incentives work, if battery backup is bolted directly to a renewable energy plant, it gets much more favorable treatment than if PG&E uses it for grid stability. So considering battery backup alongside what you all are considering for behind-the-meter renewables here makes a lot of sense, and it may be much more viable than in other places. It's getting much better, and there are a bunch of companies out there looking at it very hard. If you're very interested in it, they'd be interested in talking to you.
Excellent. Has your company been involved, or do you know of any wind power companies who have been involved with municipal power districts, such as what the Marin area is trying to do? And what is the possibility of teaming up with a natural gas provider generating plant for backup?
I guess it's community choice. What are they doing in choice aggregators, aggregation? We have not looked at that specifically, but we are looking definitely at wind and thermal gas-fired power plants at on-site and large at large energy users. Think of a cement plant that is using 40 megawatts constantly of power to produce California cement, and that would be a natural fit for 40 megawatts of wind with 40 megawatts of thermal feeding the excess thermal load into potentially a process. It's hard to get in there, but potentially a process. But absolutely looking at it. And a lot of people are looking at it. It's not, it's not just me, but a lot of people are looking at it, especially with natural gas at $250 a decatherm. So.
In your power purchase agreements where you own and operate facility equipment, who gets the credit for the carbon offset? Who pays for what it says PPP? Does 1 milliwatt or 1 MW power the same number of small homes as the 1 MW tidal plant? Is special supporting infrastructure needed?
So typically, we're very flexible around carbon credits, green tags, white tags, renewable energy certificates. Typically, if we take them, we monetize them and sell them into the market, and then reduce your power price. Companies that are being regulated under AB 32 are looking at those credits and saying, I need them because I'm a carbon producer. So they typically take some, maybe half of the carbon credits, bank those credits in hopes that they will satisfy regulation either nationally or from a statewide level. A megawatt when it's fully producing a megawatt, it's just with renewables, I would think the tidal is probably around the same capacity factors. So, a megawatt is a megawatt, and we typically run about 25 to 45% capacity factors, depending on the wind speed.
One last question. Some researchers at the Monterey Bay Aquarium reported that some companies have designed a wind propeller resembling the fin of a whale that is supposed to be incredibly more efficient than currently used designs. Are you familiar with this new design or any other new designs?
There's a lot of new designs out there. I have not seen the one that looks like a whale's tail, but there's venture capital money going into a lot of different designs. We'll see what becomes commercial, and if they do become commercial. I'm sure companies like my old company, Siemens, and companies like GE will be looking at that technology and buying that technology.
Thank you so much, Matthew. I've learned so much tonight. This is great. Our last batter is David Hernandez, is the project manager at Chevron Energy Solutions. Thank you, David.
All right. Well, it's my pleasure to be here tonight. Thank you all for having an interest in renewable energy, and especially renewable energy in Benicia. So what I wanted to talk about tonight, and it's nice going last because a lot of the financial and economics of renewable energy have been discussed a little bit by my colleagues up here, and it really sort of applies to the different technologies fairly equally. So what I was going to concentrate on is first explaining, what Chevron Energy Solutions is. There may be some questions out there about why is Chevron involved with renewable energy. So just a little bit of time on that. Then talk about different solar technologies, what's out there, what's being commercially applied right now in terms of solar technology and the different types of systems. And then to focus in on what Benicia has done with the renewable energy program that we're just wrapping up pretty much right now as we speak, and discuss how that's, what kind of positive impacts that's having for the city of Benicia. So you can go on. Chevron Energy Solutions was actually, we are a division of Chevron Global, and we were initially started about 11 or 12 years ago with the primary goal to reduce our own energy consumption within the existing facilities owned and operated by Chevron. With fairly immediate successes with that, they decided to break off the division and make offerings to primarily public sector clients. As the slide shows, we try to be a one-stop shop for any customer, whether they're public or private, and take care of everything from the energy analysis, the program planning, design, engineering, the procurement of all the materials, panels, construction materials, and then the actual construction itself, and try to wrap that into a single development agreement that makes it a lot easier to manage. Next slide, please. Although I'm speaking primarily about solar tonight, Chevron Energy Solutions firmly believes that a fully integrated approach to economic and environmentally sound planning on your energy usage is the best way to go about it. One of the little catchphrases, I don't have as many acronyms as this guy here, but the catchphrase we like to say is negawatts before megawatts. In other words, reduce your current consumption. By reducing your current consumption through a variety of measures, that's going to have the greatest fiscal impact and savings on your energy bill. And then once you've done that, you right-size your renewable energy, whether it's wind or solar or anything else, to help offset the remaining electric load that you would have at your facility. And we performed a full study and analysis like that for the city of Benicia for all their larger energy-using sites, and came back with a plan that was approved for implementation. And a big part of that plan was the solar photovoltaic installations that we're doing at different project sites, which I'll get into in a little bit later. We do focus in on public sector clients. Our primary client types are the K-12 schools, colleges, cities and counties, and other and federal government. There are some reasons for that that certainly pertain to the financing with PPA structures versus other financial structures, but your public sector clients, of course, don't pay a tax bill. Therefore, they don't receive directly any tax credits because they don't have a tax bill. So there's just a different approach you would take to public sector clients versus private sector clients who have different opportunities on the financial side of things. So with that being said, I'll jump into a discussion of the different types of solar systems that are currently being implemented. There's all sorts of technology being studied, as you could imagine, and I'm sure a lot of you out there have heard about different types of systems going in. But what's out there right now really focus around the solar photovoltaic technology, and there's different types of products out there that utilize solar photovoltaics, and then there's solar thermal. What solar photovoltaic really means is it directly converts sunlight into electricity. There's different types of panels and different types of cells that all do the same thing chemically that make that happen. And I'll kind of talk specifically more about the different types of systems that were analyzed here for use in Benicia. Fixed orientation systems are primarily utilized in areas where you don't want any moving parts and have a good opportunity for orientation towards, in this location, primarily south, the southern orientation. There are single axis tracking systems which will basically have your panels set up in long rows, and in the morning they're kind of tilted over to the east, to the morning sun, and they basically track the sun from east to west as you progress through the day. Those kind of systems produce a lot more kilowatt hours per kilowatt of installation, so you could look at, some would say, more bang for the buck with a system like that than one that's a fixed system. And then there are dual axis tracking systems, which there's actually a few of them out here in American Canyon and in Napa County I've seen. They look kind of more like what you would describe as like a satellite dish, and those track both east to west as well as north and south. So in the winter months it would be directed more horizontally, and in the summer it would be tilted up, and also day to day it would go north to south. Then those have the maximum output in terms of kilowatt hours produced per hour of sunlight or per kilowatt of panel installed. Solar thermal, I think a lot of residential folks are familiar with solar thermal. It was probably the first type of solar energy that was developed, and literally it just transfers the heat that any of us feel when we are out in the sun into usually water. You put these panels out in the sun, they heat up the water that goes through them, and then you can use that hot water either for domestic use or for heating swimming pools as a very good application for that. Then there's concentrated solar thermal, in which mirrors are used, usually in some sort of parabolic shape that are, and they also are almost always tracking type of systems, and they capture more sunlight over a broader area and then focus it in on a much smaller area, generally a tube with some highly thermal conductive material in there. It's basically like an antifreeze type of material is what it is. And they focus all that thermal energy on a small space and superheat that thermal fluid, and then that's put through a heat exchanger to either create steam for a steam generator or any other high pressure application through a turbine to create electricity. That really kind of sums up what's being done right now and implemented out there at a commercial or even residential level of application, but there is certainly all sorts of technology that's being looked into right now, or different forms of these same concepts to try to make them more efficient and more reliable and cost effective. Next slide. So solar photovoltaic, that's what we are implementing here in the city of Benicia. Underneath in the heading there in the blue box, all of those city properties are receiving different sizes of solar photovoltaic installations here. The construction is pretty much complete with the exception of one site, and the systems are coming online literally as we speak. The first ones have started to come online. The structure types that we're implementing here are the first two. We're putting in a number of what we call canopy structures, typically installed in parking lots. So you take a space that's already developed, it's already being used, and you actually enhance it by putting up a shade structure for the cars, and at the same time providing a dual use for the area of not just parking, but also parking and photovoltaic panels. There's a great example of this right behind us here, and I encourage anybody to go take a look at it after this symposium is complete. The middle picture shows as an example of a ground mount system that we installed up at Merritt College in Oakland. We have four sites of ground mount solar installation here in Benicia, and that particular type of installation right now is the most cost effective because you don't have to pay for as much structure like the canopy system has, and everything being on the ground makes it more efficient in the construction phase for the guys doing the wiring and et cetera. So it's not just the structure cost, but the actual labor cost is, they're not up on ladders or on scissor lifts. They can just literally walk behind these things and do all the wiring and get these systems installed. So Benicia, fortunately, was able to take advantage of this type of system because they had properties that were high energy users and had enough property around them to that didn't have some future use in mind for it to install ground mount systems. The last picture shows an example of a tracking system that's actually a rooftop tracking system. They don't have to be on rooftops. We did not decide to use tracking systems here in Benicia for a variety of reasons. Like a lot of city and other public sector entities these days, budget cuts have been brutal, to say the least, and there is a little bit more maintenance involved with tracking systems, a little bit more hands-on effort there, and it just didn't seem like a good fit for what we were trying to accomplish, which was to help lower the city's budget output, not add another layer of complexity to it. But those are just pictorial examples of the different PV type of mounting systems. Next slide. On the solar thermal side, again, like I said, I think one of the most common use for solar thermal and most efficient and good use is for heating swimming pools or swim centers. This is a rooftop solar thermal application on the left there at a city's swim center. We looked at this for the city of Benicia and their swim center, and there's still an opportunity there. It's just the amount of space available there is very limited, and of course no one wants to cut down trees, and they tend to cast shadows on these systems. So we are putting up a small solar photovoltaic system there, though, and getting some energy use that way. But back to solar thermal, so just, preheating the water that goes into a boiler just reduces the energy use of the boiler system dramatically. And then the other picture is an example of what I was talking about before with the concentrated solar thermal. You can see the parabolic shaped mirrors, and hopefully you can see the small pipe running down the middle of each of those carries the fluid that gets superheated and then pushed into a steam generation facility. Next slide. Okay, so now I'm going to talk even more specifically about Benicia. Benicia, we responded to an RFQ that they put out with the wonderful and great foresight to literally immediately start making progress against the goals dictated by the Climate Action Plan that was developed and approved by the City Council here. And I think they deserve a lot of applause for their foresight in not just developing a climate action plan, which I think a lot of cities have thought about, but somehow never seem to get the wheels behind it, and then to provide the metrics within that plan that they've set these goals. They're going to achieve them by certain dates. It was a very aggressive plan, and it takes some right-thinking people to really commit to that. And so right on the heels of that plan, they asked for help in achieving the goals. So we came in as literally an energy advisor as well as an implementer, but to study their energy use and then propose measures that could help them reach the goals of their climate action plan. The green list shows the different photovoltaic system sizes that we are installing at the different facilities owned by the city of Benicia. And the bottom line is 1.67 megawatts, which for a city this size is really a great accomplishment. As it says up there, it's going to offset 62% of the energy used at the sites that we're installing, which is a great result. So, the next few slides kind of are just a few specific examples of what we're doing here, and I picked different types of systems to show. This is an aerial view of the City Hall parking lot, and you can see a little bit of the swim center down there in the corner too. That was a Google image taken before the whole parking lot renovation. So when we put these images of the canopy arrays there, we were trying to imagine what the revised parking lot would be like. So it was very more or less symbolic of what we were planning to do. And again, I encourage you, for those who aren't already parked back there, it's even at nighttime, the canopies have lights underneath them, so you can get a real good idea of what we did. So these are elevated parking lot canopy structures supporting the PV system. Next slide. This is an aerial image of, actually a satellite image of pump station number 1. The blue shape there represents the area where we installed a ground mount system. The pump station, which is the little building just across the road from the ground mount system there, I believe we were talking again about how expensive it is to move water around, but that's one of the responsibilities the city has, is providing potable water. And so these pumping stations, and they have a few of them, they eat up a lot of energy, and they're also pretty much demand response type of stations where people want their water. They're not going to wait for the tank to fill up. So they pretty much have to pump when they've got to pump based on demand, unless they want to build enormous storage facilities. So it was a very good candidate. The pumping stations are great candidates for solar. One of the nice things, and again, my colleagues mentioned it before, the time of use for offsetting your own electrical usage makes a big difference in the economics. And it's sort of the one part about solar that is best, is solar systems are producing the most energy when energy is the most expensive. So that's one of the reasons they can sometimes be economically viable. It all depends on your rates and your usage profiles. But what's nice is that, let's say in a school, a lot of schools are out for the summer. You have these huge solar systems operating during the summer. producing huge amounts of electricity, even though the school is barely operational. They might have an event now and then. But luckily, one of the good things about the regulations the way they are right now is that the net energy metering payback is PG&E looks at your total yearly consumption of energy, not what you consume and use at the exact same time. So it's literally as simple as this system over the course of a year produced this much energy at these different times during the day and night, and that's got a certain value to PG&E as if they were billing you for that energy, and they just subtract that from your energy usage. So it puts solar in a good position to give excellent return on investment, if you will, in that it's producing power when that power is the most valuable. And the last slide is the one and only rooftop system that we're installing here in Benicia. That's a picture of their fire station number 12, and we've put a small rooftop system there to offset the energy at that spot. So those are the 3 types of systems we're installing here. And let's see what this final page is. And here's the next slide is sort of the fun facts about what Benicia has been able to accomplish through the implementation of this program. When all the system is complete and operational, it will reduce greenhouse gas emissions by 1,900 carbon dioxide equivalent metric tons. And you can give me the abbreviation for that, but that's a lot. That's a lot of metric tons of carbon that are not going into the air. Again, a lot of questions and answers are already answered. So it's absolutely true that by using this clean renewable energy, that means that some dirty power plant somewhere is not having to create that energy and put it on the grid. So it absolutely does have a direct effect on the carbon reduction in the environment. The greenhouse gas emissions, there's these, the EPA actually has a greenhouse gas calculator. So these aren't things that were drummed up by somebody's marketing department or anything like that. It's a calculator that anybody can go online and use to get equivalencies. And so this reduction of greenhouse gas is equivalent to over 9,000 cars being off the roads over the course of 25 years. And the production is warranted for 25 years, so that's where the 25 years is coming from. It's also equivalent to over 400 acres of pine forest, what that acreage of forest would sequester in greenhouse gas emissions. So it'd be like planting 400 acres around Benicia of pine forest to help clean that greenhouse gas out of the air. The Benicia's council, of course, were very interested in meeting the goals of their climate action plan, but they, again, with budgets being what they are, they certainly had fiscal goals in mind and fiscal responsibilities to keep in mind. And this program that's nearing completion will have a positive impact for the city's budgets, and some of that comes from the PG&E incentives, which were garnered through the California Solar Initiative. The systems installed here will result in over $1.5 million over the 5 years of the California Solar Initiative directly into the coffers of the city of Benicia. And even with all the upfront costs and the finance costs and all the different costs that goes into these things, this system was able to fund completely out of savings, over program savings, major capital improvements like the City Hall parking lot back here. As you can imagine, the solar systems, they have a direct payback for being there and for offsetting electricity. But in this case, the entire parking lot was demolished and rebuilt in a much more sustainable fashion and a much more efficient parking fashion, and with shaded canopies. And I think it's just a really good example of a more holistic approach, as well as really taking a property like this with great historic value and being able to improve it without going to the community for a single dollar to do that. The next slides are kind of fun. The first one, this is what the parking lot used to look like behind City Hall. Up to 10-foot tall concrete retaining wall that was literally leaning over the sidewalk, big cracks, ugly stains. Had a couple of Quonset huts there that you can see a little bit of on the right side that were storing a bunch of unused materials. A really narrow entry stairwell from the street there that was kind of almost like alley-like. And a really strange parking layout, I guess is the best adjective I can come up with. I mean, they're trying to maneuver around the Quonset huts, and for the amount of space they had, certainly not an efficient parking layout. And then what we have now is this. This, of course, was a computer-generated photo rendering of what it would look like when it's complete, but the actual real thing out there actually looks very much like this. I think, and most folks would agree, it's a fairly dramatic improvement. So, that's it.
Thank you so much. Well, I'm certainly glad I came tonight. We don't have as many questions. I think we're getting low blood sugar out there. But there is a question. Does Chevron have a test windmill in Benicia now? And what does it show? And does Chevron Energy Solutions do wind also?
So to the second part of the question, yes, Chevron Energy Solution does do wind study and wind power implementation if that's what makes sense for the customer, and given all the conditions that were described before with wind potential, the type of economic vehicle that's being used, all play a factor on whether that makes sense or not. But yes, we have projects that in place with wind. We are a little bit more open to and willing to implement smaller wind turbines, such as somebody asked a question about a 6-foot diameter turbine. Those tend to work sometimes better for the smaller loads that we're looking at with some of the facilities, and can be installed in more residential or occupied environments without the same concern for a big giant tower being, over someone's house or something like that, because they're much smaller and can be, along ridge lines of buildings and used that way. We've had only a few installations in the neighborhood of the type of turbines that Foundation Wind Tower puts up, but we do have a few of those in the Midwest and in the Northwest. The other part of the question.
Do you do wind also? I think you answered.
There was a question about a wind study here.
Windmill installation.
Right. The testing systems that are usually installed are called Met towers. So they're actually little tiny windmills, so that we wouldn't call them so much a windmill, but the city certainly has an option to do that with us. We have included it as a potential scope. Right now, I think they're looking at various options. The thing about putting up a Met tower is you need to be pretty close to the location and the height, which is sort of the size of the wind turbine that you're going to install, for that data to be really meaningful. So until that is determined, then that's when you would put up your Met tower to figure out what the specific wind potentials are at a site.
And we have one. How long are the solar panels supposed to last that are being installed in Benicia? And when that time expires, will Benicia have to invest a similar dollar amount to get new equipment?
So that's a really good question. The panels that are installed here are, I would say, of the highest commercial grade available out there. They are warranted for 25 years, extremely high levels of efficiency for commercial panels. The thing about 25 years, that's a warranty. It's like a warranty on a lot of things, the car or a dishwasher or anything else. Its potential life can go well beyond the warranty period. There are no moving parts in photovoltaic panels. There's some of the earlier models that were installed maybe 10 years ago are still operating just fine, 10 or even 15 years ago, and the technology has moved vastly since those were installed. So the panels that are going in now are, they're backed by the manufacturer for 25 years. They have degradation factors The good ones, like we're installing here, in the neighborhood of 0.07% a year, or 0.7% a year, excuse me. What they're finding is that degradation happens quicker in the first few years, maybe the first 5 years, and starts to level out. So no one really knows right now how long these panels can continue to produce power. There is a degradation, but at year 25, I believe they're still calculated to be producing about 80% of the brand new installed power. So after the 25 years, there should be much more useful life in the system.
There's a similar question. What is the balance of life cycle cost versus payback, number of years to payback? Specifically address maintenance costs. And then we have one, how can you convince shopping center developers and owners to go solar over the parking lots and roofs? These lots represent massive amounts of hot asphalt, heat generators, and islands.
Okay, again, really good questions. On the maintenance costs or life cycle cost, that is certainly something that the city looked very, very hard at, and it was part of the reports that we put together that were scrutinized to the highest level. It can be handled lots of different ways. If the goal of the customer is to not have any out-of-pocket expenditures, then those costs are calculated, they're predicted to hopefully in a very conservative manner, and rolled in to the total cost of the system that's being paid for by whatever type of financial vehicle the customer decides to use. That's not up to us. We'll do these programs under a PPA like Foundation Wind does, or under any other type of financing. Again, we're talking about public sector clients. A lot of times they have bond funds or ability to get other sort of tax-exempt lease structures. So under a PPA agreement, the long-term maintenance is usually a very specific and well-defined item because some very smart people in financial institutions own these systems. But I think Benicia did a very good job of making sure all of these costs were very well laid out and included in those costs are basically included in the overall finance structure that the city is using to pay for the systems. The other question, parking lots, right? This is something that we've at CES tried to figure out too. The thing about shopping center parking lots is typically one developer or company owns the entire center, and they lease this space to some small shops, and there's usually a big anchor store, maybe a couple big anchor stores and a bunch of little guys, and they all have their share of that parking lot, so to speak. It's all used. The different stores are used to calculate how big the lot's got to be, as well as the rooftop areas. That was part of the question too. So it kind of complicates things. I think the simple answer would be is when it becomes financially viable for the developer to include that system in the base cost of the rental to their eventual occupiers, by saying, well, because we got the system out here, you're gonna have lower utility bills or something like that. It's certainly more complicated than a direct customer energy user situation. So we found that to sort of economically to be a tough nut to crack.
We also have, someone has asked, has anyone developed a combination wind and solar system? If so, where are they in use?
There are larger, what we call grid-scale power farms that do have combinations of wind and solar. The systems, though, really aren't combined. They operate completely independently, but it's a way of sort of making more use of the space. I mean, wind can blow at night. You're never going to get solar production at night. So it's a way of rounding out the grid production of a given site. Of course, large wind towers would cast a lot of shadows too, so there's got to be some forethought. And normally you'd want the wind turbines on the north end of the site, and then all your solar down there. They're out there. I don't know the details of them, but I haven't heard of, say, a windmill tower with solar panels stuck on it or anything like that.
Yeah, I'd say Anheuser-Busch has a megawatt of solar, and we're right next to it with the 1.5 megawatt of wind turbines. So a Sun Edison system and a Foundation Wind Power system supplying a lot of Anheuser-Busch's load. So there is, there's more large-scale grid tied wind, solar, thermal type of projects and behind-the-meter type of projects. But there's an example, 20 miles away or 15 miles away.
So at this juncture, I just want to, at this point, anybody who would like to put in a card for any of the three panelists, you should feel free to do that. I have been asked, though, to facilitate going down in this world, right? Facilitate a conversation really between all three of you, where has there something come up tonight that you would like to comment on, reflect on, or ask a question about of one another? Because I think we're all interested in what would be the best public policy, not just for this community, but for communities in general, for the state of California, for our nation, to become more energy efficient as well as more, less damaging to the environment.
Well, I'll make a brief comment. I don't know if it's so much a question, but hopefully one of my colleagues can add on to it. And it was mentioned, about AB 30, is it 32? AB 32, yeah. The AB 32 is it's an assembly bill that was put forward and had a lot of momentum a few years ago, and it's stalled out for various reasons. But for public entities, especially cities, counties, and school districts, entities that have lots of different facilities scattered over a given area, each with their own independent electric meter, some using a lot of energy, some using just a little bit of energy, and maybe they also own property. AB 32 would be a great bill to pass that would help companies like ours and the application of renewable energy technologies like we do. What it would allow is for you to take advantage of an area that, for whatever reason, whether it's political or wind potential or thermal potential, to generate power there, put it onto the grid, and get the same benefit from that power economically as if you were building it at the site, offsetting the meter right at the site. The economic regulations by PG&E right now do not currently make that concept economically viable, but the intent of AB 32 was to make it viable. And I think if again, you're the public, some of you are actually in local politics, to put pressure to get that assembly bill moving again, could certainly help make a lot more of these technologies economically viable.
Yeah, and I would say I think it's really important for both at the state, national, and local level that we talk about renewables, we talk about these things, we make sure that our private sector clients are acting on AB 32, and then the federal, state, and local level, they don't act on the same type of. And thank you, Benicia, for acting on it. But too often, public agencies don't act on climate plans that have been implemented. They force private companies to act on it, and then they don't act on it themselves. And then we just need, at the state level, I think we have some very good bills, AB 920, that allows everybody to get paid for that electricity that goes excess electricity to the grid. So there's good things coming out of the state legislature, and hopefully we have just more coherent and consistent policy, both at a national level and a state and local level.
These guys are probably going to throw stuff at me for saying this because we're all in the business of selling power one way or the other, but the best way to be more sustainable and to save money is to use less energy. Now, having said that, I don't know a single guy who's going to buy a smaller flat screen TV when his breaks. And I don't know a single woman that's going to buy a less powerful microwave or hairdryer. We use more energy in everything we buy all the time. And we did talk about time of use, and we used to go try to find guys, users, industrial users, that could shift their time of production to least expensive times of production. People don't want to work the graveyard shift, but very intensive energy industries can save a lot of money by operating at night because power is cheaper. The reason power is cheaper at night is there's a daily curve of everybody wanting to use it, and as you have to make more during the day as a utility company, you have to bring more assets online making energy. If we can flatten that curve out, by doing so, you move your usage into more cheap times a day. Those are ways to be more sustainable. Having said all that, renewable energy, it's important to recognize that it does also reduce NOx and SOx. NOx are nitrous oxides and SOx are sulfur oxides. All those things that put mercury in the air and in the ocean that make us not eat enough sushi. I like to eat tuna more than once a month, but we're not supposed to because it's at the top of the food chain and it's accumulating mercury from eating all the other stuff. And the mercury comes from coal power plants in Asia, where we get our sushi from. So those are my thoughts on sustainability. But we'll sell you more renewable power if you want to do that.
One of our audience has asked, do you have a marketing plan for AB 32 cap and trade market? Anybody?
Well, I think we're addressing AB 32 with some of our larger customers, specifically the cement industry in California, that will be regulated under AB 32. It's not directly around carbon sequestration, but offsetting some of their power use. But I would say there is an incredible amount of investment being made primarily by large industrial users around carbon sequestration. If you ask any of the big cement players what types of technologies that they will venture capital like back, it will be around carbon sequestration.
Now here's one where you get out your crystal balls. Can you predict what will happen with federal tax credits on renewable energy? If they die, how will this impact the renewable industry?
We all want to make a guess? My bet is that the production tax credits won't be extended until after the presidential election. They won't get addressed, and then they'll get extended as is by 1 year, and they'll sunset slowly after that. The rate of slow decay on how much they will be extended will be a matter of a lot of discussion, but I don't think we're going to hear a lot about it until the next big election happens.
Well, I'm not part of our federal group, and I'm not sure exactly where the federal tax credits apply, but we certainly have a similar situation here in California with the California Solar Initiative. And so I can speak a little bit just in terms of real history, because this California Solar Initiative recently, at the end of last year, basically evaporated. And it was a stepped program with the whole intent being that you first players that are willing to make the leap and jump into solar in California, we're going to give you, this much money per kilowatt hour that your system produces back to you. But that was in blocks, that as those blocks got used up, that amount of money that comes back was going down. And as long as CSI was around, it was still tricky. It was still very difficult to make a project pencil out, but you could do it. And then so they basically evaporated last year. They got refunded a little bit this year, but when they were gone, when the California Solar Initiative rebates were gone, the idea was that the industry would catch up, that as more and more solar got put out there, it would become more and more efficient, there'd be more competition, the products would get better, et cetera, et cetera. Well, the money evaporated faster than technology could improve, and keep up with it. So without it, it makes it, you have to have really special uses and energy consumption profiles to really make it economically viable. It's tough. It's tough without the assistance of whether it's a federal credit or CSI or some sort of tax-related assistance on these projects on the solar side.
Yeah, on the federal side, we were in D.C. 2 or 3 weeks ago with the WIA lobbying days. I would agree with John. Probably post November, potentially into early part of next year. And the only other prediction I have, it's going to be retroactive to the beginning of 2013. And I think PTC, ITC, and the 1603 grant all get extended for only 1 year.
Millions for defense, but not 1 cent for tribute. It really does seem like, given the investments we've made in certain aspects of defense because of our concerns about energy, that it would be nice to invest here in America in investment that would help our next generation of kids to live better lives and to not be dependent on foreign oil. It just seems like it. But who am I? If the PV panels convert 30% of the solar energy that strike them, where does the other 70% go? Santa Claus?
Well, I'm not, a scientist or engineer in the solar panel production industry, but I've seen enough graphs and illustrations. I also know that folks like NASA and JPL have developed photovoltaic technology that can capture way beyond that, but it's not economically viable to produce those panels, and even for the extra efficiency, the cost of production goes out the roof. So there's always that balance of, how efficient is it versus how much does it cost to produce and install. And but I can't specifically answer the question about where those extra photons and electrons. Well, heat's everything, right? I suppose so. He says heat. So I'm sorry, I can't be more specific.
Well, lastly, I want to give you all a chance to make some closing comments. And specifically, if you were advising leaders of either party or all 12 parties, whatever it is, what would you say, whether they're policymakers here in Benicia or policymakers in Sacramento or policymakers in Washington, D.C.? What should and could we be doing to promote more energy alternatives sooner, such that we could protect the next generation from the kinds of strange involvements that we seem to get into in odd places and odd times?
Well, I think the key is, having, consistent long-term policy around renewable generation, energy efficiency, all of those things. This stop and go around yearly around projects that take 4 or 5 years to permit and build and study and all of those things it's just crazy. So we have a long-term policy. And then we do need breakthroughs, and not only funding. I think we need to start funding basic research around energy. Right, get money into our university systems, our University of California system, so we can have even these incremental breakthroughs are so huge. So basic research, a consistent policy. Mostly, I think we have a better consistent policy in California than we do at the federal level. So I think having California take some leadership there, and hopefully at the federal level they'll get a more consistent policy. You look at Obama's State of the Union address. He is running on renewables and running on energy. So hopefully, strong and long-term policy comes out of that.
I don't have any more to that.
The administration's done a pretty good job of getting money to Department of Energy, and the acronym I couldn't remember was EERE, which is the Energy Efficiency and Renewable Energy Department of the Department of Energy. DOE has a million departments. I really don't know how many there are. But EERE is the stuff that pertains to all the things we're talking about, and they've got really good information if you want to go research any of the things we've been talking about. Lots and lots of very flash web pages with lots of information in them. We're doing a decent job at funding research and development. We're not doing a decent job, in my opinion, of helping projects to pencil out pro formas that work. And what we've been referring to with PTCs, which are production tax credits, or ITCs, which are investment tax credits, rather than funding projects on the front end, which is politically untenable, our government funds projects on the back end with tax credits. And what we were talking about earlier with investment tax credits, put the money in the project. As soon as the project is built, you get your tax credits. And that worked at Altamont in the early days. Production tax credits give money as you produce energy from the project, so it matters. But this is how we fund things. What we've been talking about, for those of you that are unaware, production tax credits expire. The wind is to expire at the end of 2012, is that right? Goes away completely. So right now, it's a large component of the financing package of how we can make a project work. But if you can't get your project beginning operation by end of 2012, in the current political environment, that entire piece of financing is gone, which makes it really hard for guys smarter than us to try to put projects together without that. So the whole industry is in a wait and hold. And we've seen this, and what we're referring to is that we've had a go, stop, go, stop, go, stop approach to renewables since the 80s due to political winds of change. We don't have a consistent national energy policy. It's not written, it's not stated, because there's so many different fractious constituencies that all want to keep getting funded, whether it's the coal industry or the gas industry or the wind industry or the ocean renewable development, whatever. I feel pretty strongly we need an all-of-the-above approach, and I think it's interesting that President Obama has adopted that, because I first heard Secretary of Energy Spencer Abraham say that 10 years ago, and he clearly worked for another guy. But we do, and it's interesting for all of us to consider these things. It's also interesting to be aware of what goes where. When we talk about energy, there are several components of energy. We're in the selling electricity business. Energy also includes oil, and 80% of our oil goes to transportation. Everything that moves right now uses fuel because they can't be plugged in. Having said that, electric cars are great, except you realize you're plugging them into dirty power plants. They don't get plugged straight into a wind turbine, a solar panel, or an ocean energy thing. They go to cheap power. On the East Coast, your electric car is a coal-powered car. It may be nuclear-powered in other places. But you've asked interesting questions, and I think it's important to back off and get a 50,000-foot view of all the things we're talking about, because they're all interrelated. And a lot of our politics is about this, and being informed as to what we're actually doing with our hair dryers, big screens, plug-in cars is a component, and I applaud this city for taking initiative to try and approach their usage and their use of production more intelligently. Thanks for having us here.
Ladies and gentlemen, I hope you will join me in thanking John and David and Matt, who did such a fabulous job tonight. I'm glad I wasn't home watching my big screen. I really don't care much about my hairdryer. But I'm really glad I was here tonight, and I thank the mayor and all the members of the commission, my dear friend Constance, all of you for what you're doing. You are really leading California in a very positive way. Thanks to our panelists. Thanks. Great pleasure meeting you.